Happy Friday, everybody. Happy Friday. The weekend's come almost. You just got to make it through this last day of classes. I'll see you on Monday. But here is the lesson for Friday. So our goal today is to find out what the total of any shape is, their angles added up will be. So it's what? It's called the sum of interior polygons. The interior sum of polygons is what it's called. So we want to know what the angles on the inside of polygons add up to be. And there's a really cool trick that we can figure out by finding a pattern, looking at a bunch of different polygons here. And it has to do with yesterday's assignment that said all triangles add up to 180 degrees. So what we have to do here is we're going to draw all the possible diagonals from one vertex. And when we say diagonals, we mean from a corner to a corner. So if we did a triangle, I'm picking a vertex, a corner. If I wanted to draw to another corner, I really can't. I'd be going to that corner, I'd be going to this corner, and there's already lines there, so that doesn't work. So a triangle would already be done. We drew all the lines. Next, a quadrilateral. In this case, it's a square, so I'm going to pick this corner right here. I'm going to draw all possible diagonals. Well, there's one. I don't think I can draw any more diagonals from that single corner, so I'm done. Next up, a pentagon. A pentagon has 5 sides. I'm going to pick that corner to start, and well, there's the diagonal right there. The next diagonal would be over 1. And then I wouldn't have any more diagonals. Those would just be straight lines, so I'd be done. I've driven all my diagonals. So we're doing pretty well. We're drawing diagonals. Let's go to a hexagon. I'm going to pick my favorite corner. This time I'll go on the bottom. Sure, why not? I'm going to draw from corner to corner here, kind of making triangles. So here's one triangle on the inside. Here's 2 triangles, another diagonal, corner to corner. Here's 3, and that's it. I can't draw any more. The heptagon. Let's go on the right side this time. It doesn't matter what corner you pick, as long as you pick one. I'm going to draw straight across here. There's one diagonal. Here's another diagonal. Here's another diagonal. I'm just going corner to corner. And then this one wouldn't count, right? If I drew from this corner to this corner, or this corner to this corner, it's a straight. You're not cutting the shape in any way. All right, an octagon. Let's see. Let's go here. Well, I can't go straight up, so I have to go corner to corner this way. Corner to corner across. Corner to corner across. And it starts to kind of look like a seashell, a little bit. The more sides we get, and that's fine. That's what it should kind of look like. But I'm just trying to cut it into as many triangles as I possibly can. All right. Octagon is done. Time for a nonagon. Non just means 9, so I'm going to just pick the top one this time. Let's see. I can't go there, so I have to go here. There's 1, 2, 3... Just going from corner to corner to corner to corner to corner to corner to corner. Perfect. We got it. Done with the nonagon. Time for a decagon. That's a 10-sided figure. I'm going to just pick this one right here. So let's see. I'm cutting it on the diagonals, making triangles. It's starting to look even more like a seashell here. Do-do-do-do. Do-do-do-do. Corner to corner. It's kind of a little bit slow, but that's okay. We ain't got no rush to get through this. All right, now time for a dodecagon. That means a 12-sided. Dodeca means 12. I'm going to pick this one this time. Let's see. I'm going to go. That would be a triangle. Corner to corner. Vertex to vertex. I should use the math word. The fancy math word for corner is vertex. I don't know if I've told you guys this yet. Mathematicians really think they're smart, and so they tend to use fancy sounding words to make them sound smarter. They're a little bit pretentious, but that's okay. That's why I tend to use the more simple words. But I know all the big words, and it's good to know them. That way, when someone says it, you don't feel like you're lost. All right, we've done all our shapes. We've cut them into as many triangles on the diagonals as possible. So let's fill out this little chart here. So the first thing is the number of sides. So a triangle, let's start there. A triangle has 3 sides. That's that middle number. So I'm going to put 3 sides down. Okay, 3 sides. Now we want to know how many triangles are in a triangle. Well, that's kind of a stupid question. There's 1 triangle in a triangle. So I'm going to go down. All right, 1. And then we know the sum of the angle of a triangle is 180 degrees. We did that yesterday. That was the triangle sum theory. All 3 angles in a triangle add up to 180 degrees. Perfect. On to the quadrilateral, or the square. So a quadrilateral has 4 sides. So we'd put 4 in this box. Now, how many triangles did we cut it into on the inside? Well, we have 1 triangle here. We got 2 triangles there. So we got 2 triangles in a quadrilateral, or 4-sided figure. Well, if there are 2 triangles, and we know a triangle adds up to 180, all we'd have to go is 180 times 2, because we have 2 triangles now, right? Let's see, 0, 16, carry the 1, 3. 360 degrees would be the total sum of the inside angles of a square. So if I want to look at this a little bit differently, here's our quadrilateral. This angle plus this angle plus this angle plus this angle all add up to 360 degrees. And in the case of a square, they're all 90. 90 plus 90 plus 90 plus 90. We could double check. 0. 9 plus 9 is 18. Plus 9 is 27. Plus 9 is 36. We'd get our 360 degrees. So any shape, any 4-sided shape, like this one right here, these 4 angles would add up to 360 degrees. I find this kind of cool. We're taking any shape we want, we split it into a bunch of triangles, and we can find out what the sum of their inside angles are. That's crazy, just because we know what a triangle is equal to. So let's keep doing this. All right, a pentagon. A pentagon has 5 sides. We have 1, 2, 3 triangles on the inside. I'm going to scroll down and find 3 triangles. Well, 3 triangles would mean I have 180 degrees per triangle times the 3 triangles. That'd be 0. That'd be 24. Carry the 2. 640 degrees on the inside of a pentagon, or a 5-sided figure. That means if I wanted to, I could add up all 5 of these. 1, 2, 3, 4, 5, or any 5-sided figure. Right? Oops. Any 5-sided figure, and they could add up to 640 degrees. Whoops. Be 540 degrees. I did my math there. Even the best of us do our math wrong. 3 times 1 is 3 plus 2 is 5. So it'd be 540 degrees. All right. On to the 6-sided figure, a hexagon. Well, we know we're going to need the triangle, so let's just count them right now. 1, 2, 3, 4. All right, so a 6-sided figure has 4 triangles. That would be 180 times 4. 180 degrees per triangle times 4. Let's see, that'd be 0, 32. So it would be 720 degrees. And you can use your calculator to punch that out. You're just multiplying 180 times the number of triangles. And so any 6-sided figure would add up to 720 degrees. All right, let's go to a heptagon. A heptagon is a 7-sided figure, so I'm going to put 7 down. It has 1, 2, 3, 4, 5 triangles on the inside. And some of you might be seeing a pattern on how these two numbers relate. That will come in more into play. So let's see, 5. Well, now I have to do 180 times 5. That'd be 900 degrees. That'd be what? Yeah, 500 times 80. Or 500 plus 400. 900 degrees. Yep. Any 7-sided figure has the inside angles add up to 900 degrees. That's crazy. We could figure out all of these if we wanted to. All of them add up to 900 degrees. Always, every single time. Isn't that crazy? That's wild. All right. On to the octagon. An octagon has 8 sides. Maybe by now you figured out what this is. If you look how these two relate, it's always the same thing. How did I get from 5 to 3? How did I get to 6 to 4? How did I get from 7 to 5? Well, we'll do this one the old-fashioned way the first time. 1, 2, 4, 5, 6. Maybe some of you figured out this was 6. Perfect. And now we can do 180 times 6. And that would be 1080 degrees. So any octagon, all the inside angles add up to 1080 degrees. Super cool. Awesome. All right, time to look at the pattern. If I had a 9-sided figure, all I did every time was subtract 2 from however many sides I had. So if I have a 9-sided figure, there'll be 7 triangles on the inside. And we should be able to go up and count. 1, 2, 3, 4, 5, 6, 7. It works. And we got 7. We're just subtracting 2 from the number of sides. So this would be 180 degrees times 7. Again, it's because triangles have 180 degrees on the inside. That's from yesterday. And we'd get 1,800 degrees. Nope, that's wrong. We get 1,000. Sorry, 1,000 would be 180, 06, 1,260 degrees. Awesome. 180 times 7 is 1,260 degrees. All right, if we have the 10-sided figure, we're going to subtract 2. We'd have 8 triangles on the inside. Let's go count, see if it's right. 1, 2, 3, 4, 5, 6, 7, 8. Oh, it worked perfectly. So now we have to go 180 times 8. That would give us our total degrees. How cool, man. That'd be 0, 4, 1,340 degrees. What if we had the 12-sided figure up here? It should be 10 triangles on the inside. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It came out perfectly. We're just subtracting 2. So I go 10, or 180 times 10. You get 1,800. That's how many degrees are inside a 12-sided figure. It's pretty crazy that it works out like that. And in fact, if we just said the number of sides was the letter N, right? This could be any number. The number of triangles on the inside would just be subtracting 2 from it. And to find the total degrees, we'd go N minus 2 times 180. And we could find our degrees. It's a special formula. It's the interior angles of a polygon. All right. We're going to use this information in today's lesson. You have a worksheet in the IXL. The worksheet looks like this. They give you a bunch of whatever sided figures they want, and they want either the sum or just one interior angle. I gotta switch colors here so you can see. I'll switch to black. So example, let's go with a 16gon, number 3. Well, 16gon just means that there's 16 sides in the figure. So if I want to know the sum of the measures of the interior angles, what we are doing up here, right, I'm going to use this formula, n minus 2 times 180. So n is the number of sides. So it'd be 16 minus 2 times 180. So 16 minus 2 is 14. I times by 180, and I would get the number of degrees on the inside of a polygon of a 16-sided figure. Well, I punch that in my calculator. That would be 1,800 plus 720. Oh, I can just use a calculator here. Let's open it up. It's easier this way. What was it? 14 times 180. Boom. 2,520. So my answer here would be 2,520 degrees. That'd be the total on the inside. That's for the first 6. Perfect. The last 6, they're asking for just one angle. So what we do is we do the same thing as up here, but then we have to divide by the number of sides. So this gets a little tricky. Let's look at a number 11, a 38-sided figure. So the first thing we need to do is find the total inside angles, add it up together. So I go 38 minus 2 times 180. That'd be 36 times 180. So I punch this in, 36 times 180, boom, 6,480. This would be the total. This would be the answer for the ones up here. But we're not doing that. We need to find one angle. Not just every angle. We need to find one angle. So what we do after that is we take our total, 6,480 degrees, and we divide it by the number of sides. Well, the number of sides was at 38gon. So we divide by 38. So I go back to my calculator and go 6,480 divided by 38. That gets me back to 170.5. So my final answer would be 170.5 degrees. You should never, down here, get 180 degrees. That shouldn't happen. You shouldn't do that. The second part of the assignment is in IXL. As I said, so if I open this up, it's W, I believe, where is it? 13 interior angles of polygons. It's asking you for the same thing. So we would count up how many sides this is. 1, 2, 3, 4, 5. We know our formula is the number of sides minus 2 times 180. So 5 minus 2 is 3. Times 180, I punch that in my calculator, I get 540 degrees. And I could punch this in here. Oh, let me get rid of this. 140. Boom. Perfect. That's what you're doing. And I could do another one. I count the sides. 1, 2, 3, 4, 5, 6. Our formula says the number of sides minus 2 times 180. So this would be 4 times 180. So our interior angles would add up to 4 times 180, which is 720 degrees. Oh, get out of here. 720 degrees. Pretty straightforward. Happy Friday. I'll see you on Monday. If you have questions on this, send me an email over the weekend. I'll try to get to it. If I don't, Monday is a great day to ask. Well, you can always slow down and do more of both of these Thursday and Friday's assignments so you get them. Do your best. Thank you. Enjoy your weekend.